Let's pinpoint one more helpful method with which you can use the piezo buzzer and output data to the serial port. In programming, and especially in the creation of cyber-physical devices, where programming is also present, there is one very important stage, which is called debugging, and which is aimed to correct errors. In order to correct an error, we need to find it first. In the development environment, programmers use special methods for this, which help run the program step by step and not all at once. They can also monitor what is happening at every exact moment. The standard Arduino environment does not offer this option. However, we can use some additional methods. For instance, we can insert commands on the creation of sounds in a certain section of the program. If we have doubts about the correct operation of this segment, if we don't hear a buzz, then the program has been run correctly up until this segment. We can then move this command following the code. If we want to find out where exactly the error has occurred, if we work with data and we are not sure that all the calculations were correct, we can output the values of the variables into a serial port. Or we can just send a message there which will indicate that we have reached a certain section of the program. Let's modify our previous sketch a bit, the one where we receive digits from the computer and then output these digits to the 7-segment display. In order to understand what exactly I am talking about, I have remastered the program a bit by adding the pin of the buzzer, which I placed in the center of the diagram, and then writing some debug lines. Let's imagine that we are sending a digit from the computer, but the semi-segment does not display anything. There can be various reasons for this, from the fact that we might not have connected the wire to the possibility that our shift register is not working. We need to understand where exactly the problem lies. First things first, we need to check using the code if there is anything in the buffer, and if anything has been transmitted through the serial port. I have added a comment, got data, to the output of the serial port, which literally means that some data has been received. Thus, if we can read this message there, then the data keeps coming. If we don't see this message, we need to figure out why. Maybe we did not set the connection, or the speed is different. There can be numerous options. Let's imagine that we have discovered that data keeps coming, but nothing has appeared on the display. Possibly, for some reason, our comparison does not work, meaning that this condition is considered false, despite this 0 that we sent. This could literally be anything. I am going to add a 3 kilohertz beep here with the duration of 1 second. Now, if we get 0 and hear a beep and don't see anything on the display, we are experiencing a problem with the output of the data to the display. If worst comes to worst, you need to make sure that the bulk of the program is run only if the data from the computer is received correctly. It can be so that the data has not been received for some reason. And what if the controller does not work at all? Let's make sure that the program is in the working condition and add one more output to the serial port at the end of the loop, which we shall name end of loop. The program has run all the way up till here. If something is wrong, it will be inside this section and in the serial available function. Now, let's see how it works. I am starting the port monitor and sending the 1 command. We have received whole 4 messages. Why 4? We have received got data because something has been transmitted to the buffer. The cycle has come to its end. This we have also studied before. Why then did we get the same 2 messages once again? I have already attracted your attention to this new line. In fact, when we were sending a message, From the computer, apart from the symbols that we entered, there was one more symbol added at the end, the symbol of the new line which we can't actually see. That's why we get these messages twice. What will happen if I transmit 0 through the monitor? As I expected, we can hear a beep in this section, where we discovered that the digit variable equals 0. This is a simple way of applying one more method of using the piezo buzzer and the output to the serial port in order to monitor how the program runs and find possible errors. Now, if something goes wrong, you can easily find this out and not stay in limbo anymore.